All right, hi guys. This is the inverse trig functions notes. So if you look on the left side, what we have are the three trig functions we talked about: sine, cosine, and tangent. And what those were functions where if you input an angle measure, the output would be a ratio from a right triangle. So if for sine, if we input an angle measure, our output is going to be the ratio of the opposite side of a right triangle over its hypotenuse. If you input a angle measure into the cosine function, the output is going to be the adjacent side on a right triangle over the hypotenuse. And tangent, you'll get opposite over adjacent. So you're inputting an angle measure, and the output is going to be a ratio. Okay, that ratio could be represented as a fraction, or we could have had it represented as a decimal. Okay, what we're going to do today is the inverse trig functions. So you're going to do the reverse. You're going to input the ratio, and the output is going to be the angle measure. So if we input the ratio of opposite to hypotenuse in a right triangle, it'll then tell us what that angle would be. So the input is the ratio, and the output is going to be the angle measure. Okay. So if we go down and let's look at some examples here. For A, we have the tangent of A equals 1.5, so I'm going to write it down here. Tangent A, I'm going to give myself a little bit of room, equals 1.5. Okay, 1.5. Right, so the reason these are called inverse trig functions is because they basically cancel out the regular trig functions. So if you were multiplying by 5 and you wanted to get rid of the 5, you have to do the inverse operation to get rid of it, to cancel it out. You have to divide by 5. If you have something that's squared and you want to get rid of the square, you got to take the square root, because the square root's going to cancel out that square. All right, so we're doing the same thing here. So if we do the inverse tangent, okay, on both sides, right, we take the inverse tangent of both sides, right? The inverse tangent and the tangent will cancel out, and you're left with A, the angle measure, right, equals the inverse tangent of 1.5. Okay, and then you would go over to your calculator. Okay, we'll just use the Google calculator. Okay, on this calculator, and it might be different depending on what you're using. Here we have the inverse button. So we're going to click, first of all, we're going to make sure we're in degrees. Then we're going to click the inverse button, and we want to do inverse tangent. Okay, arctan is the same as inverse tangent of 1.5. Okay. We hit enter, and it's going to tell us 56.3. And we'll do 2 decimal places, so let's call it 56.31. Okay, or let's read the directions. To the nearest tenth, so they just want 1 decimal place, so 56.3. Okay, so again, what we did here is we said that A was equal to the inverse tangent of 1.5. Okay, and we got 56.3, 56.3. So over here, we're going to do the same thing, right? A is going to be equal to the, right, if you do the inverse tangent on both sides, we're going to get inverse tangent 0.25. Okay, so we go to our calculator, make sure we're in degrees, we're going to hit the inverse button, and we want to do inverse tan or arctan, right? Inverse tan is the same as arctan. And then it's 0.25. So 0.25, we hit enter, and it tells us 14. We want to round to the 10th place, so that's 1 decimal. So 14.0. Okay, so that's going to be 14.0. Then same thing over here. A is going to be equal to, this time it's sine, so we're going to take the inverse sine of both sides, right, or the arcsine of 0.88. That is our ratio. Okay, so we go to our calculator, We're going to make sure we're in degrees. We're going to do inverse, and we want the arcsine of 0.88. So 0.88. And we hit enter. And we get, again, we want to go down to the 10th place. So 1.07, that 7 is going to cause the 0 to go up to 1. So it's going to be 1.1. And we would do the same thing for all the rest. Here, A would equal the inverse sine of 0.52. Here, A would equal the inverse cosine of 0.48. Right, you just put those in the calculator, and then here A would equal the inverse cosine of 0.33. Okay. And you would just put those in the calculator to get your answers there. Okay. So now let's look at an example of each, the inverse sine, inverse cosine, and inverse tangent being used to find an angle in a right triangle. So you want to do the same thing that you did for the trig functions. The first thing you want to do is label your hypotenuse. So here's our hypotenuse. Okay. You want to circle the angle in question. And then is the 8 opposite or adjacent? Okay, opposite is across, adjacent is next to. So adjacent would be the one next to it. The 8 is across, so the 8 is opposite. Okay, and we're still using our mnemonic, SOHCAHTOA. So SOHCAHTOA. Okay, we have the hypotenuse and the opposite. So we have the H and the O. That's going to give us sine. Okay, but because we're solving for an angle measure rather than the side, we are going to use the inverse sine function. Okay, so inverse sine. So we can say the inverse sine, okay, of our ratio. So opposite over hypotenuse, the 8's opposite, 11's hypotenuse, so 8 over 11. Okay, and that's going to be equal to our angle measure, and in this case, the angle measure is x. So all we have to do is go over to our calculator, make sure we're in degrees, because we're using degrees. Were we in radians for the last one, maybe? It's possible. Okay, make sure we're in degrees. Okay, and we want inverse sine, so you got to hit the inverse button. Okay, inverse sine, and our ratio is 8 divided by 11. So in the parentheses, we're going to do 8 divided by 11. Okay, and we're going to hit equals, and it's going to tell us 46.65 degrees. So I'm going to round that up to 46.7 degrees. 46.7 degrees is going to be our value of x. Okay. All right, let's do the next one. Okay, so first step is to label your hypotenuse. So here's our hypotenuse. Second step is to circle the angle we're looking at. Here's our angle x. Okay, is the 8 next to or across from? It's next to. Next to is adjacent. So this is our adjacent side. Okay, if we use our mnemonic, SOHCAHTOA. Okay, we're going to use cosine, right? Because adjacent over hypotenuse, we have the A and the H, so that's the ka, so that's cosine. And since we're solving for an angle, we're going to use the inverse cosine. Okay, so all we do is follow the formula. Cosine, right, inverse cosine, and then our ratio is adjacent over hypotenuse, so that's 8 over 18. And that's going to equal theta, which is our angle measure, in this case, x. Okay, we go over to our calculator, make sure you're in degrees. We do inverse cosine, which is the same as arc cosine. Then we put in our ratio, which was 8 divided by 18. And we hit enter, and that's 63.6. So 63.6 degrees is x. And then the last one, our hypotenuse is across from the right angle. Okay, but we don't have any information down there. Circle the angle. Across is opposite. Next to is adjacent. Okay, if we use our mnemonics, so katoa. Okay, we have the opposite and the adjacent. That's the O and the A. So that's the TOA part. So we're going to use the tangent function. Okay, but we're solving for an angle, so we want to use the inverse tangent, right? We want to use this one down here. So inverse tangent, and then we put in our ratio, opposite over adjacent. So opposite is 4, adjacent is 5. So 4 over 5. And that's going to equal our angle measure, which in this case is x. We go to our calculator, make sure you're in degrees. We're going to do inverse tangent, and it's 4 over 5, or 0.8. Okay, we hit enter, and that's going to be 38.7 degrees. We're going to round up to 38. Okay. Make sure we have our decimal point in there. 38.7 degrees. So for the inverse trig functions, you're using these when you're solving for the angle, right? You would use the regular trig functions when you're solving for a side. When you're solving for an angle, you're using the inverse trig functions. You're inputting the ratio into the inverse function. The output is going to be the angle measure that you're using. Okay, so again, this should help you finish the inverse trig worksheet and also the Khan Academy exercise. Again, let me know if you have any questions or want me to do more examples.